everyone. This side Dr. Amit Kumar Pandey from ABES Engineering College. Today I am going to discuss round robin CPU scheduling algorithm. So let's check what is inside. Here are topics which will be covered in this lecture. First is introduction, then basic of round robin CPU scheduling algorithm, then time quantum and advantage and disadvantage of round robin CPU scheduling algorithm. Then we conclude this lecture at the end. So what is round robin CPU scheduling algorithm? RR is a widely used CPU scheduling algorithm. It ensures fair allocation of CPU time among processes, improving responsiveness in time sharing system. Round robin CPU scheduling method is a method where each process is assigned a fixed time slot or maybe called time quantum and processes are scheduled in a circular order. Each process in the ready queue gets an equal share of CPU time and processes are executed in first come, first serve order but preempted after the given time constraint or after given time quantum. Now, check what is time quantum. So, time quantum or time slice is a fixed time period for which a process is allowed to run before being preempted. So how to choose time quantum or quantity of time quantum? If we take too small time quantum, then it will increase context switching overhead. And if we opt very large time quantum, then your round robin CPU scheduling algorithm will act like as FCFS CPU scheduling algorithm. So we must opt a optimal value for time quantum. Advantage of round robin CPU scheduling algorithm versus fairness means all processes get an equal share of CPU time. Responsiveness, this algorithm is suitable for time sharing system and reducing waiting time for process. And this is very simple to learn and very easy to implement. Now, see what are the disadvantages of round robin CPU scheduling algorithm. First is overhead. In this algorithm, frequent context switches can lead to high overhead if the time quantum is too small, or this round robin CPU scheduling algorithm is not suitable, not ideal for process with varying execution time or process with high priorities. Here we can see a flow diagram for round robin CPU scheduling algorithm. As you can see, here is a ready queue in which all the processes which want to get execute are stored and processor will fetch one process at a time from the ready queue and start execution. And now if the burst time of the selected process is less than time quantum, then okay, it will execute completely and will get terminated. Okay. Else means if the burst time of selected process is greater than time quantum, then this process will execute for provided or given time quantum period and again go to the ready queue for its next chance for execution. And this cycle will retain until that process will completely execute and terminate. For better understanding, here is a numerical. So let's see how to solve the numerical of round robin CPU scheduling algorithm. Here we can see here are five processes P1, P2, P3, P4, P5 with their respective arrival time 0, 1, 2, 3, 4 and respective burst time 5, 3, 1, 2, 3. Okay. So we have to prepare two queue. First ready queue. This is ready queue. And second is Gantt chart for document the execution. Ready queue is what is for ready queue? We use ready queue for maintaining the order of execution. And here is Gantt chart. From here, we will get all the detailed information about execution of the processes. So at the time of 0, there is only one process inside ready queue P1. When CPU want to start execution at the time 0, then it will seek for process in the ready queue. There is only one process P1, so it will fetch P1 for execution. Now, this is constraint. The maximum time for execution at a single chance is defined by time quantum is 2 unit. So we cannot execute any process more than 2 unit in a single chance. So processor will execute P1 for 2 unit 0 to 2. Now remaining burst time of P1 will be 3. Meanwhile, we can see here two process has arrived inside ready queue at 1 unit time P2 and at 2 unit time P3. So here are more process P2 and P3. Okay, after 2 unit, there are 3 process P1, P2, P3. P1 got a chance and execute for 2 units, so we will preempt P1. We will preempt P1 and fetch next process which is P2 for execution. Again, CPU will execute P2 for 2 unit times. So now time will be 4. And remaining time is 1 for P2. Now time is 4. As we can see, there are 2 more processes which has arrived in ready queue P4 and P5. P4 and P5. Now we will preempt P2. So P2 will go again in ready queue. So next chance is for P3. We took P3. Now, as we can see, the bus time for P3 is only 1. So CPU will invest only 1 unit time for execution of P3 4 to 5. Now P3 has completely execute and will terminate. It will not go inside the ready queue again. So P3 is finished. Now again turn is for P1. 5 to 7, 2 unit. Remaining is 1. Now P1 again will go to the ready queue. Now this is turn for P4. 7 to 9, and we can see the complete burst time of P4 is 2. So it will complete execute and will terminate. P4 will not go inside ready queue again. Next chance is for P5. As we can see, the burst time is 3. So the processor will give at max 2 unit time, 9 to 11. 2 unit time, remaining time is 1. And we will preempt P5. Processor will preempt P5. So it will again go to the ready queue. Now this is turn for P2. The remaining burst time is 1. So 11 to 12. Now P2 will finish completely. Will get terminate. Now this is chance for P1. The remaining burst time of P1 is 1. So 12 to 13, P1 will get terminate. Now this is chance for P5. The remaining bus time for P5 is 1. It also get terminate. Will execute completely. P5 13 to 14. So with the help of ready queue, we maintain the order of execution. Now the common asking in every question in CPU scheduling is to tell average waiting time or average turnaround time. So we will calculate average waiting time and average turnaround time with the help of this Gantt chart. So here is a fresh slide. Make this Gantt chart again. Starting from 0 to 2 P1, 2 to 4 P2, 4 to 5 P3, 5 to 7 P1, 7 to 9 P4, 9 to 11 P5, 11 to 12 P2, 12 to 13 P1, and 13 to 14 P5. This is the Gantt chart for above numerical. So now we want to calculate average turnaround time 80-80. So for calculation of 80-80, first we have to calculate individual TAT for every process. TAT, TAT for P1, TAT for P2, TAT for P3, and TAT for P4, and TAT for P5. So TAT is exit time minus 80 arrival time. So for P1, what is exit time? P1 exit time is 13 minus for P2 12 minus for P3 this is 5 for P4 this is 9 for P5 this is 14. Now we have to minus arrival time for every process. So arrival time is 0, 1, 2, 3, 4. Arrival time is 0, 1, 2, 3, 4. So TAT will be 13, 11, 3, 6, 10. 13, 11, 3, 6, 10. If we want to calculate average turnaround time, then we have to sum all these values, sum of all individual TATs sum of TAT PI where I is 1 to 5 divided by number of process 80. Now, if we want to calculate average waiting time, so we have to calculate individual waiting time for every process. So how can we get the waiting time? AB minus burst time of every individual process from TAT of every individual process, then we get waiting time. So for P1, for P2, for P3, for P4, for P5. TAT of P1 is 13, for P2 is 11, for P3 is 3, for P4 is 6, for P5 is 10. 13, 11, 3, 6, 10. Now, we have to check for burst time of every process. 5, 3, 1, 2, 3. 5, 3, 1, 2, 3. So waiting time will be 8 for P1, 8 for P2, 2 for P3, 4 for P4, and 7 for P5. Okay. Now, if you want to calculate average waiting time, then find out sum of all these values, means total of individual waiting time divided by number of process. In this way, we will get the value for AT-AT and AWT. Here are some references which I have used in my lecture. Thank you for being with me. Thank you all.